Hello everyone and welcome back to the new video. So in this particular video we are going to talk about how to use AWS Secrets Manager for storing secrets for our EKS cluster. Okay, so in the previous videos we have already discussed about why do we need external services in order to store the secrets for our EKS cluster, right? So we have already discussed this in the HashiCorp Vault video. So I will be pasting the link in the description. I would request all of you to first go through that video, and once you are ready with the understanding from that particular video, you can then come here and implement the AWS Secrets Manager for your storage of secrets. So that way it will be very much convenient for you to understand as well. Okay, so without wasting any time, let's get started. So in order to implement this particular scenario, we will require ESO, right? That is external secrets operator. Now in order to implement this, the pod within the cluster requires access to the secrets manager, right? Now for this particular scenario, we will be implementing IRSA. What does IRSA stand for? It stands for IAM roles for service account. So basically, we are going to implement IRSA. So now let's try to understand how IRSA works in this case. So if you are able to understand this figure, you will be able to understand what IRSA actually means. Okay, now let us consider this pod needs an access to any of the services of our AWS account. Then what we need to do is, we first need to create a service account. So pod uses this particular service account in order to access this particular service. So first we create the service account. Then pod uses a Kubernetes service account. This service account is then mapped to an IAM role which has got the permissions to access the services. Okay, once it is mapped, then the EKS OIDC provider, which is also an identity provider, okay, so OIDC will then validate your service account. So once it validates your service account, the pod calls the STS assume role with web identity. Then it provides the temporary credentials. With these temporary credentials, the pod is then able to access the AWS service. So pod will be able to access any of the service which has been mentioned inside of the policy. Okay, so in this way IRSA works. Now let's try to see the whole picture in one go. So the first important thing is that here within the EKS cluster we have got ESO service account. Now with this particular ESO service account, we will be authenticating the secrets manager with the cluster secret store. So with the help of IRSA, we will be able to fetch the credentials from the secrets manager into the external secrets, and then external secrets will be creating the native KTS secrets for us. Okay, so the entire process of IRSA over here will remain the same as how we explained earlier. So over here we have the secrets manager. With the help of this particular role, we will be able to access the secrets manager, and then this service account being mapped with this particular role will be able to access the credentials and will be able to generate the KTS secrets. So this is how the approach is, and now we are going to implement it in this particular video itself. So stay with me till the end, and this video is going to add a lot of value. Okay, so we will be making use of this particular repository for our this demo, and then we will be following all the steps that have been mentioned within the readme file itself. So all the steps are mentioned, so even if you don't watch the entire video and you just follow all the steps given here, you will be able to implement it. Okay, so let's go to the CloudShell first and try to check if we have already installed kubectl, eksctl, as well as helm. So all of these have been already installed in my CloudShell. So if you haven't installed any of these, you can just follow these commands present over here, and you will be able to achieve it. Now I will be creating an EKS cluster. So I'll just copy this command and paste it right here and enter. So it has now started the process of creating an EKS cluster. So once that's done, I will be installing external secrets in that, then the EBS CSI controller as well. Okay, because I will be implementing persistent volume claims. So in order to implement that, we will require these as well. Okay, so that's why these two things will be installing first, and then let's go to these files one by one. So first of all, service account is what is required here, right? Because we will be implementing IRSA. So for that, we will be creating the service account within the external secrets namespace itself, and then we will be providing the IAM role, which we will be creating before applying these changes. So this IAM role is going to have the permissions to access the secrets manager. Okay, so over here we will be first then creating the secrets manager. Okay, then after that we will be checking whether the OIDC is already associated with our EKS cluster or not. So once we check that, if it's not associated, we will associate it with using this particular command. Then we will be creating an IAM policy which has got the permissions to read the secrets manager. Okay, so the values we'll be able to read with this particular policy. Then we are going to create an IAM role. So there are two ways it can be created, using manually as well as using the commands. I will be showing you manually because these commands you are able to implement anyways, right? So you will be able to run these commands anyways. So what I feel is I'll be showing you the manual way of this, and otherwise you can follow this readme file, no worries at all. Then once this is done, then we will be applying all of these manifests, right? So this role is coming from this particular role that I create for the secrets manager, right, and associate it with a trust policy as well. So that role is going to validate for our service account. Then once that is done, we will be creating the cluster secret store. Now if you have watched the previous video of HashiCorp Vault, you would have understood that over here we pass the token, that is the vault token over here. But in this particular section, since we are making use of service account, we will be passing the service account reference here, where we will be also passing the namespace as well as the name to which this service account belongs to. Here I have mentioned JWT because JWT token will be used for the authentication purpose. So once this is done, once the authentication to your secrets manager is done with the help of cluster secret store, Then we can go for the external secrets, which will be creating the secrets, that is Kubernetes native secrets through this. So it will be using cluster secret store. Okay, it will be referencing it for the authentication purpose, and it will be pulling, or it will be fetching the secrets from the secrets manager, and the target will be DB credentials. So the secrets that will be created, that is the native secrets, will be of this particular name, that is DB hyphen credentials. And then over here the data. So which values do we need to fetch is what we will be mentioning right here. Then after that we will be creating a stateful set for MongoDB. Okay, and in here we will be again passing the secret references to our containers. So over here within the environment variables of the containers, you can see that we are passing the username as well as the password of my Mongo over here. Okay, so you will be able to view it, and this is nothing but the volume mounts. And since I will be making use of the volume claim templates, I have mentioned all of the details right here. Then we will be making use of a Mongo service as well. Okay, so all of these things we'll be able to create our Mongo credentials by fetching the secrets which are stored in our secrets manager. So this is how we will be able to achieve the purpose of the demo, right? So the creation is still in progress. So the cluster is getting created. Let's wait for some time. So now you can see that the cluster is up and active. If I go inside of the cluster, I can see that everything is in working condition. And if I also check the compute, 2 nodes are up and running, and I have also got the node groups over here, right? So everything seems to be in place. Now let's go to the repository to follow the subsequent steps. So the first thing that we had to do was to create an EKS cluster. So this part is already done. So the next thing that we'll be doing is to install external secrets operator. So for that we'll have to execute these commands. So let's go and execute these commands right here. So the installation process is done. Okay, so the external secrets operator has been installed. Now the foremost thing that we need to do for the EBS CSI controller is that we need to attach the policy to the role, right? So the role of our node. So let's go to the node, and in here if we go to the EC2 instances, within the instances, so if I check within the security, I get a role over here, right? So this is the role. So I'll just use this particular role. So what I'll do is I'll copy this particular command and paste it over here, and for the role name I will be just using the role name from here. Okay, I'll copy this and paste. Okay, and paste it over here and enter. So now this particular role has got this particular policy for our EBS CSI driver. Okay, now we can apply the changes. Okay, so the changes have been applied. Now let's check both the things. kubectl get all -n external secrets. So over here you can see all the pods and deployments related to the secrets have been deployed inside of the namespace external secrets. Now let's check about the EBS. kubectl get all -n kube system. So over here you can see this particular deployment of EBS CSI controller. So the controller has been deployed inside of our kube system namespace. So both of these things are done. Now once this is done, foremost thing that we need to do is create a secrets manager. So we will be executing this command. Okay, so if I go inside of here and paste, you can see that we are creating a secret string which has a username as well as a password. Enter. Okay, so I think I need to change the name. Okay, so let's change the name again. Let's keep it creds. I hope this name is available. Okay, so creds is available. So let's go over here as well and make the changes which we had made previously. So over here within the external secrets, I will have to change it to creds. So okay, so this is done from here. So once we have created the secrets, now if you go over here and refresh it, you will be able to see the secrets over here with the name prod/db creds, and you can retrieve the value from here as well. Okay, so over here you get the values in the key value format, and in here you get it in the form of plain text. So these things are ready now. Now once this is done, now it's time to work with our OIDC provider. So you can go with these steps, okay, but I will be following a manual approach. So over here within the cluster, you can see OpenID URL, right? Just copy it, okay, and go to the IAM first. Now go to the identity providers. Now what we need to do is we need to add this provider of OIDC. So this is the OID connect, and I'll just add this URL over here. Now the audience over here is sts.amazonaws.com, okay, and just add the provider. Now you can see your provider has been added. Now once you do this, you will get a prompt over here for assigning an IAM role. So click on assign IAM role. You will be creating a new role. Okay, so over here this dashboard will be open. Now over here web identity has been selected automatically. Okay, and the audience again will be sts.amazonaws.com. Then the next. Now within the permission policies, we will be selecting the Secrets Manager read-only access, because we will be just kind of reading these secret values, right? We won't be making any change. So I would rather go with this particular policy. And next, okay. And for the role name, we can refer this one. So what should be, yeah, so let's give it this particular name, that is ESO Secret Manager role. So this role description is optional, okay. So we will be creating like this only. So once your role has been created, we can make few changes there. So within the trust relationships, what we need to do is we need to edit this and kind of add one value for our service account. So what I'll do is I'll just copy this entire stuff till here. Okay. And then sub followed by the value is something that I'll take it from here itself. So this is nothing but my service account where I'm passing system colon service account colon the namespace followed by the name of my service account, so that this particular role will be mapped to this particular service account. So now this is done, okay, and I'll update the policy. So now I am done with the changes, okay. These are the similar changes which we are doing over here, okay. So you don't need to worry about it. You can follow this way also or the way I showed you. Anyways would be fine. Now, one more thing that you need to do over here is to update the role within your service account.yaml file. So just try to update it. So let's go to the role and copy this ARN and then just kind of paste it over here. It is an important step which you should consider. Okay, let me check other files also if there is any change to be done. I don't think so here there is any change required. Here I have already mentioned the DB creds over here, so there won't be any issue. And these stateful sets will be referring to the secret that we have that we'll be creating, that is the native secrets. So the name is completely different for them, so you don't need to change this thing. Just the name for the external secrets where we have defined the remote reference is what we need to change, okay. So that's what we have done. Now let's clone this particular repository over here, okay. Git clone. Okay, great. So this particular folder has been created here. Let's go inside of it. And now the foremost thing that we'll have to do is to create a service account. So I will execute this command kubectl apply -f service account.yaml. So the service account has been created. Let me check, and this will be created inside of the namespace external secrets. ctl get service account -n external secrets. So over here you can see external secrets -service account has been created, okay. Now since this is created, the next important step is to create the cluster secret store. Now this one is what is going to create a cluster secret for us and authenticate with the secrets manager as well, okay. kubectl apply -f cluster Okay, now let's check kubectl get CSS. So over here you can see AWS Secrets Manager cluster secret store has been created, which is valid and has the capability of reading as well as writing. Okay, now the next step is to apply for the external secrets. Secret.yaml. So the namespace app has not found, so I will be creating a namespace kubectl create ns app. So this namespace of app will be created. Once it is created, I will be able to create the secrets, that is the native Kubernetes secrets will be created. So external secrets -n app. So you can see the status is secret synced, so which means that it was able to sync the secrets from the secrets manager onto our EKS cluster. Now let's try to execute the command kubectl get secrets -n app. So you can see the secret of DB credentials has been created over here. Okay, so the native secrets has also been created. Now once this is done, we are free to apply the changes for our MongoDB. Apply -f mongo stateful set. Okay, so let's check the status get pods -n app. So it is in the container creating stage. Let's also check the state of the PVC. So you can see that it is in the bound stage, which means it got successfully created. Now let's try to check the pods condition, and it is in the running state now. Okay, now once both the pods are up and running, let me keep it in the watching stage. So the amount or the replicas that we have mentioned is 3. So you will be able to view the 3 different replicas right here. Okay, so 3 replicas have been created already. So let's check now. All the 3 are up and running. Now we can check one thing, that is the secrets. Are these Mongo pods getting created with the credentials that we have passed into our secrets manager? So we need to check that. So for checking, we will have to first use this particular. If we are able to successfully log in into this, then we can say that the credentials were synced properly. Okay, now the password is so now we can say that the credentials that we had put inside of our secrets manager were assigned to our MongoDB, and because of which we were successfully able to log in using those credentials. So this is what we had considered and we have achieved. So if you found this video really helpful, make sure to like, share and subscribe to the channel. And if you have any doubts related to this, you can ping them in the comment section, and I'll try my level best to answer those questions. So this was all about it, and thank you so much.